In each of these examples, things are written as mixed radicals. With mixed radicals, it's not as easy to compare which number is bigger. But in entire radicals, things are easier. So what we're going to do is we're going to take the values in A and say, I know that 5 root 2 is equal to the square root of 50. And I know that 2 root 5 is equal to the square root of 20. And now comparing those numbers, it's easy for me to see that root 50 would be bigger than root 20. And finally, 4 root 3 4 squared is 16. 16 times 3, 48. So if we were doing from greatest to least, 5 root 2 would be the greatest, then 4 root 3, and finally 2 root 5. But it's much easier to see once we change it to an entire radical. Now the step in between, because you guys figured this out, how to do this, I'm going to add, whoops, there we go. I'm going to add the step in between for you. The step in between is as follows. You know that 5 squared is 25, and the reason we change it and multiply the inside by 25, because another way that I could write 5 is the square root of 25. From here to here, does this make sense that those are the same things? Writing a 5 in front or writing the square root of 25 means the same thing. Similarly here, I could write, whoa, I don't want green, I want black. Square root of 4 times square root of 5. And square root of 16 times square root of 3. And in grade 10, you multiplied radicals together. In grade 10, you multiplied square root of 4 times square root of 5 and got square root of 20. And it fits with all the math that you've learned so far, because 4 times 5 is 20, and square root of 4 times square root of 5 is 20. Now, I point this out because it doesn't work for adding square roots. You tried to add square root of 20 and square root of 45 and got square root of 65, and it's wrong. So this is a special rule that we're allowed to do, and we're allowed to do it partially because of the patterns we noticed on that grid paper activity that we did, that this works for radicals. Adding radicals doesn't work that way, but if you have a square root times a square root, you can multiply the numbers together. And the same is true once you get to cube roots. So I have 9, and we're going to need our calculator for this one. 9 cube root of 2, 11 cube root of 2, and 8 cube root of 2. Before we can compare these, well, this one actually, I think right now you could compare them quite easily from greatest to least. Which one's going to be the biggest? 11 cube root of 2. And then 9 cube root of 2. And finally 8 cube root of 2. These ones we can compare because they're all the same cube root. So I'm not going to do any more with this one, actually. I was going to do something with the calculator, but I'll leave that for part C, because what comes up in part C in part C, we've got 3 fourth root of 8, 4 square root of 2, and 3 cube root of 5. Three fourth root of 8, 4 square root of 2, and 3 cube root of 5. Actually, it doesn't come up in this one. I will show you something in B. For C, this one's going to rely on just being able to type each of these into your calculator. So I'd like you to take your calculator out. I know that you could do 4 square root of 2, but I want to see if you can figure out how to type in these other ones as well. Okay, so pull out your calculator. Where did you find the 4th root? So I went 3, and then you said hit math. And I see a cube root, and then a number 5, it has x root. If you go to that x root, whoops, clear. 3, math, number 5. Oh, it automatically changed it to a cube root. But I can go into that and change it to a 4. And I can go back to the beginning and add a 3 out in front. Was it 3 4th root of 2? Is that what it was? 4th root of 8. Thank you. What's that? Oh, and then you have to go into and use your arrow key to get to that blank part? Does it work? Okay. So we can do 3 times, I'll put the times there, math, go down to the 5th one, 4th root, and then allows you to type that in, use your arrow key to move over, and we get 5.04. 4 square root of 2, which was our next one, that one can just be done normally. That's 5.65. And the last one was 3 cube root of 5. So 3 times math. I will use number 4 because it's already a cube root. 5.1. So the 4 square root of 2 is the largest. 3 times the cube root of 5 is second. And then the smallest one is 3 times the 4th root of 8. So this one is the biggest. This one was second, and this one was third. So I'm going to add one more question to this. And I am going to have 3 cube roots of 2, 2 cube roots of 4, and cube root of 40. And now we'll go back to non-calculator. So now we're going to compare these without our calculator. And the difference from this one and part B is the numbers inside are not the same. So I'm going to use the same technique that we did in A. In A, we changed them to entire radicals so that we could compare them. The question is, here in D, how do I change cube roots to entire radicals? In fact, the last one is already an entire radical, so there's nothing I need to do with that one. Well, in order to multiply radicals, just like you can multiply square roots and square roots, you can multiply cube roots and cube roots. So what number would I put in here if there was a 3 out in front? 27. what number would I put here if there was a 2 out in front? 8. Because the cube root of 27 is 3. The cube root of 8 is 2. And so the cube root of 27 times the cube root of 2 is the cube root of 54. The cube root of 8 times the cube root of 4 is the cube root of 32. And the cube root of 40 is still the cube root of 40. So if I was ordering these from largest to smallest, 3 cube root of 2 is the largest. 3 cube root of 40 is second, and then 2 cube root of 4 is third. So we can change things to entire radicals even if it's not a square root. But our experiences so far have been dealing with square roots. So your questions for homework are number 5 without your calculator and 9 with your calculator.